All right. Hi, everybody. Nephew SIG Automation Package Management Subproject for Thursday, April 6th. So we wanted to take some time today and talk about the function runtime proposal or code or library. Is that right, Wim?
Yeah.
But just quickly, before we do, just wanted to check in on our sprint progress. So we're basically the sprint and
Your voice is gone, John.
Sorry, every time I forget to do the sprint is done Tuesday, and we'll do planning for the next sprint then. And I'm continuing on the design of the package variant stuff. So if anybody wants to review that, the link is in the issue. I'm definitely not going to get to any implementation this sprint, so this can move. I guess we have Liam here, and is that who is that?
That's Isti.
That's Isti. Okay, so both. Okay, so and then that's Anne. Okay, yeah. So I would want to discuss. There was. Are you guys okay with? So there is at least part of Nokia that has signed the Google CLA. So in theory.
Yes. But it's in a specific project, I think, John. So I have been involved in that. It's in open config. It was a whole battle to get it done.
Okay.
But yeah, so they limited us to in that particular project. So it's part of open config that I know.
Okay.
So they are constrained to that and only that functionality. So
wow.
So it's very limited. I know I've been personally involved, so that's why.
Okay. The
as regards me, I mean, coming on Nephew is okay for because we already have kind of agreements in place with the Linux Foundation, but if we go into anything else, it could be a big. It would be a battle that I probably wouldn't take on.
Right.
With the legal department, sure. So
yeah, I totally agree. I mean, I tried to take some battles. Obviously, I failed.
Okay. Well, we did
with that department, the legal. Yeah.
What I have noted is that we have submitted CAP to be part of CNCF, but we're waiting on CNCF's sort of application process. So that could take months. So I don't know what we can do beyond that right now, unless we were to implement part of it within Nephew. But we don't need to talk about that here. We want to get to the function runtime stuff. I just wanted to bring up that I had found that out, and but it sounds like you already knew that, and there's no real new information there. So otherwise, on the sprint board, I don't know what I seem to have filtered. Oh, I see. I filtered by.
Isti. You filtered on Isti.
Yeah. I didn't mean to do that. Okay.
I think Liam is making progress, right, on the package management, on the example implementation, I think.
Yeah, there was a lot less to it than I thought, but so thanks for all the help, Vim, the clarification. So I think it should be, have a look at what's there now. It should be better.
Okay, so the idea is not just to put the package together, but then to think through, like, if I deploy that package, what configurations do I need to resolve, and how is the user going to put those in? So like when you go to deploy that package, you can go and you can edit the resources that are in the package, and then how do those edits flow through the whole topology? Like we talked about in the example, we run into a problem, for instance, when we're doing cross-cluster things, that the IP may not have been allocated by a load balancer, say. So we have we can sidestep that in our particular case because we are controlling those IP addresses in those external networks via the IPAM piece, and so we can get around that. But the idea is to try to identify if there are additional types of issues like that that are added by the complexity of network functions as opposed to the service, the network service that I did. So that's kind of the idea is to just see where we're landing. I know there's application config, right? So like meaning by application config, I mean like the config map that's created. Like there's probably modifications needed to that ultimately in our ideal world would be handled by an operator. But we don't necessarily have that operator yet. So I just mostly the point I'm trying to make, mostly it's an exercise in trying to surface, sorry, I didn't see the hand because I was on the other tab, trying to surface other new requirements. So whoever was first, I don't know who was first.
I think I was first, but we have identified one which came out of the orange discussion, is that the SMF needs to have the UPF information in it to be able to function. So we have, so if you say you have 3 UPFs, the SMF package should contain that.
Okay, so the SMF package, what information does it need to know about them?
Actually, the IP address. So in other words,
Yeah, the info IPs.
yeah. So what we, by the way,
Can you mute Stephen?
the way it would work if we inject a CR to say IP address with a query indication in that package, we would it would do the job.
So we can, what we talked about, that if we need more than one IP returned from the IPAM, or is it something different?
No. So here, what is the scenario is the following: is that apparently, and that's specific to Free 5GC, but actually it would be good to show this because it's actually resolving inter-NF dependencies.
Yes.
Which is similar to what you actually presented for the DNS, right? Okay. Is that, yeah. What is needed is that, for example, it's a little bit of a challenge with, I don't know whether the package management can do it, but the thing is the following: if you decide that somehow there is 3 UPFs needed, let's say I put 3, you should add that into the SMF package.
Right.
And what you should add is basically say, what is the IP for the UPF? So basically that would be a set of labels or something like that contain, right? Or just a cluster or something. And what we would do during specialization, just look up what IP was assigned and then inject that in the SMF deployment. And then that would do the job.
Okay, I'll have a look at that.
Yeah, let's talk about that. We don't.
Yeah, it's a bit of a more communicated topic, I think.
Yeah, we don't need to dig into it here. We're supposed to stick to the status, and we can. And we want to have time for your other things. So let's put a note on the issue that you've identified this, explain it, and then we can talk about it on Slack, or if we need to meet, we can meet and go into depth on different ways to solve that problem.
Yeah. Okay.
Yeah.
Yeah, Leon. Sorry.
No, I was just listening there to. I just wanted to say that we probably just need to have a look at the parameters that's in each of those packages and look for kind of cross dependencies and
Exactly.
see if there's that. Yeah. That's all I wanted to say.
Okay, awesome. Yeah, so good. That would be the next step on that then. All right, to try and move it along a little quicker. I don't know if Sandeep is. Well, I guess we don't have that many on here. Is Sandeep here? Let me create 2 windows because I can't see both things at the same time.
So one thing I wanted to ask you, John, that I was planning to do all these things, right? At the end of, say, Monday or sometime, whatever is in progress one, I'll just move it to sprint 2.
Yeah, that makes sense.
Yeah.
Okay. I don't see Sandeep online, so let's move to The next one, we have a meeting tomorrow on this. I think that's progressing. If yeah, I don't see Ganesh, so that's fine. Wim and whoever else is involved with this, are we good here? I saw some discussions on
I
here.
think we have, I think Vich reached out, but I couldn't do yesterday, but I will ping him after this meeting to see when we can meet. So he pinged me yesterday, but I was busy, so I need to, but I have, there is progress in the issue list itself.
Okay.
So it's not that nothing has been done, but it's, yeah, there has been progress, but it's not completely resolved.
Okay, that's fine.
Yeah, and
Yeah.
myself and Ravi also meeting, but maybe I should also get Ravi into that meeting with you, probably. He's
Okay,
going to be
maybe we can
available
do it
only
after this. I can do after this call if you want.
looks like Ravi is going to be available only after 11:30 PST. So we can discuss offline.
Ping me. Yeah.
So that story is a bit more about requirements. I think we have enough meat at this point of time, I guess. Probably it's just about agreeing upon whether we have enough and then closing it. I think Wim has put a lot of scenarios and topologies there. Then I have put the notes about what we discussed yesterday, how we can iteratively create the test bed to achieve the goals that we want. I have a feeling that particular story has enough meat because it's more about gathering the requirements of how we want to construct the test bed. So
Okay, well, once the team that needs to implement those requirements decides it's clear enough, they can.
Yeah, exactly.
Yeah. Stephen, the NF topology controller. So, how do you want to proceed with this? What's your thinking right now?
Hello, can you guys hear me?
Yes.
Oh, good. Because I thought it wasn't. Hey. So, how do I proceed? So this is more like an evolution from the seed. So one of these is we want to finalize. I think I'm gonna take a look at the. I'm gonna take a look at Vim's topology CL and see how that would be integrated, and then evolving that piece to be invoking the package variant set CL.
Okay.
To management
so what I would ask you to do is maybe break this down into a couple issues, because right now it's just one giant block, and then we can stick them on sprints. That's probably the next step.
Okay.
Is Victor here? No, I don't think so. Okay. Does anybody else have comment on this particular item? Okay. And Liam, it sounds like you are making progress on this. We talked about already.
Yep.
This one, like I said, I'll move it out of the sprint because I'm not going to be able to implement it this time, or we are not going to be able to implement it. And this is a subtask of that one. Vish, did you have anything more you wanted to say on this today, or we're still?
No. I think one of the things you also mentioned yesterday was this doesn't have to be completed in this sprint. It can spill over to next sprint also.
Yeah.
That is what you mentioned. Want to confirm that?
Yeah, absolutely. Probably we can just, okay. Then I'm sorry, I'm trying to rush through it because I want to leave as much time as possible for the other stuff. So I think we're good. Any other comments on this, or shall we move on to the function runtime piece? All right, Wim, the floor is yours.
All right. You see my screen? I'll put it in. You see my screen?
Yes.
Yes. Yeah.
Yes.
Yeah. So what is to give you some context a little bit. So if you look in the POC, I wrote a bunch of things on the fly and in a hurry. We had, I believe, if you look to the code, it's actually very bad code. And we also did not really do full lifecycle management. We were happy that we were going to inject a resource. But for example, if there would be changes or something like that, it was not dealt with properly, right? So our goal was to actually, when we started, we said, okay, how can we build a set of libraries and make it more reusable and try to avoid all this duplicated code and stuff like that? as well as try to handle the full lifecycle management that needs to happen on package specialization. So what do I mean with changes? For example, let's say in a package today, let's say for UPF, we say there is 3 interfaces. Let's say the package changed and there is now 2 interfaces. Or we change, or we say the package says this interface, the name is still the same, but it's no longer connected to this network. It's connected to another network and stuff like that. So there could be potential various changes that are that are done on the either the blueprint, so probably on the blueprint package that would be handled upon, and the changes would need to be dealt with inside of the specialization thing, right? So as a result, these functions, they somehow need to deal with that. And that's something we did not do during the POC. And so we wanted to do that. The second thing actually the thing that led to this was that when we were designing the functions, so last week, we actually came up with a pattern that we could reuse, because what you see is that in order to handle, for example, that lifecycle management, you actually see you have to say what is there right now, what is the new thing that we got. You have to do some comparisons or diffing, as we call it, and based on that you have to act, right? So that means that based on that information, or that functionality will be replicated in all the functions. So we said, okay, is there another way that we could build a library, which we call the function runtime, that does that for us? So basically, we found a set of patterns that we believe are repeatable and could then be reused. Yeah, John.
Are these for functions or for specializers?
Doesn't matter, actually.
Okay. Okay, because the functions have to be idempotent, so you're saying like it's just sort of like when
they are
run.
the same. Yeah, so they are for both, basically.
Okay.
Yeah. So yeah, I just wanted to I call this is my new team on what we are doing in specialization. I call it the conditional dance, or what I think some people call it the choreography, right? So what we are actually doing is a set of independent actors, right, which are either functions or controllers that achieve together a common goal, right? So that's actually, so that's my representation of what we are trying to do in specialization. Now, what we have seen is that these actors get a role inside of that dance, right? So you see that actually there is roles in that. But if you then look at that whole set together, you see that they have a lot of analogy with the controller, right? Because if you talk about lifecycle management, that's what basically the controller handles. And you see that when you typically want to deal with all that change management, then you actually have a lot of analogy to a single controller. So we said, okay, and then we found a pattern in that, in the sense that, and okay, we call it upstream and downstream function, which we'll talk about it, but you see that you have a set of functions that act upon the beginning, if you will. We call it upstream. I don't know whether it's a good name, but Akash basically suggested that, so I found it okay. And so you see that there is actually 2 types of actors, and of course there is some variations into it. And that's what we are or what we have implemented in the function runtime. It's still it's a prototype that we then leveraged in order to actually do a first implementation of these functions, right? And this slide shows if you look to in specialization, we basically have 6 things. So we have interface function, DNN function, IPAM controller, and VLAN controller, and then actually IPAM specializer and VLAN specializer. I will change the name, but they are controllers, if you will, and then an NAD function and an NF deploy function. So these are the 6 that we have. So based on that pattern, so what I try to represent on the right-hand side, maybe. So today what we have a CAP package. There is an SDK that the CAP team has that we leverage, right? So that's what we were building upon. And then what if you look at the function runtime where it sits, is actually built on top of that kept function SDK, right? And right now, the implementation of our functions and or the controller for the IPAM, they would leverage that runtime to implement their specific, let's say, acting or actor role inside of the choreography itself, right? Now, what that allows us to do is, one is that all that, let's say, common code is put in that function runtime. So it means that none of these functions actually have to deal with diffing or looking if it's ready, if they are ready. So all of that code is sitting in that runtime. So that means that writing these functions becomes a lot easier. And that was our objective, that they only have code that is specific to what the acting role they have to do within that choreography, and only that. And I have an example. So it's sometimes better to show an example. And I have an example without and with. Okay. And you see that so we reduced the code by a factor of 3. Yeah, so, and of course, this does not mean that this is the only way that we can write these functions, right? So what we see is that so it's not that we are saying, okay, this is the only way on which you can write functions, but if we can, if this pattern works out, it would be, because what you see is that writing these functions right now is fairly straightforward if you go with that approach.
Okay, cool.
Okay. So now, as I was saying, is there is quite a lot of analogy with the controller behavior. And I use, of course, the controller runtime as a baseline. I pasted in the information that Bala had in the PR. So this is some information where people could find what a for and an on and a watch is. So I try to summarize it here a little bit, and what we are doing. Actually, this should be function runtime on cap package, right? So to go through it, I think it might be interesting. So typically a controller work with a reconciliation trigger, right? So that's done by the controller runtime. Here, Porch is actually our, let's say, triggering actor, right? Because he either, and there is 2 ways or 2 things. So in the case of a function, he has the pipeline, right? So there is the pipeline that he executes. And then if you look to the watcher on the package variant, the package, variant, I think it is. No, not the variant, the package revisions. It will schedule at regular time for these controllers to act, right?
So for functions, you'd also potentially have just people running kept manually too, right?
Yes, correct. Yeah. But I was in the context of what we
Yeah.
here. Yeah, that's true. Yeah. So this is specific to running it in Porch, basically, okay. Right? But you have, of course, other mechanisms. So we modeled the runtime, the function runtime in the similar to the way that the controller runtime models it.
Okay.
And the reason it's a bit of you could have various opinions on that, whether that is the right way or not. But typically each of these functions, because we also wanted to have these functions do one thing and only one thing, right? So that's why, what is that one thing? They act on a for. That's what they are focused upon at the end of the day. And then they have the own, you could say, these are, I call them child resources. So I call for sometimes the parent, so where you act upon. The own is children, right? So that you sometimes create or need in order to deliver your thing. And then you have a watch, which is here we are using it to get extra KRM, which is needed to do something with or get extra information on something like that. So that's how we model it. It's not exactly the same, and so so it can be good and bad. We could change the names. I have no problem with that, but I try to make a bit of.
No, this is great. Actually, I like it. And in fact, I'll say this, but I think maybe put it in the back of your head and then forget it or something, but because that's what I did with it. But I was thinking about this the other day. I'm like, we're doing all this manipulation just as if we were an operator on runtime. Instead of storing things in Git, what if we just stuck an API server without any actuation controllers out there and stored resources directly in a Kubernetes server, but we could use
Yeah,
boxes. But it's kind of insane, and I think it would cause all kinds of other issues. So I don't even want to like. I mean, that would be like an R7 thing. Like I don't even want to go there. But it's a thought that's, oh God. See, I should have kept my mouth shut. We got
No.
Tal and then Jean Marie. Yeah.
Yeah, I'm glad you raised it. Well, definitely not going to delve into it because it's a big thing. But I want to underscore something. It came up today during some ORAM discussions we had about declarative there. I just want to point out something. A lot of times we use the term CRD. Actually, many of our resources are never defined as CRs in a management cluster. Right? I think generally our language should be KRM resources, which by the way, Wim, you do that here. You actually say child KRM resource. You don't call it a CR, right? And that's a very, very important distinction. We sometimes lose it, but it's true. For now, many of our resources, we do have a management cluster, but we're accessing these resources via the package revision resources resource. They actually live in Git, which is kind of a staging environment for us. I use that term sometimes, but we never actually apply these resources in a cluster.
Right. They actually are marked local config, so they're explicitly excluded from being applied.
Right. This is part of the configuration as data philosophy. We're definitely doing that, but we're not actually creating these as CRs. So there's a little gap here. We have a tiny little missing feature where we never actually validate those resources using a CRD, right? A CRD has the API, the Open API v3 schema that the Kubernetes API server usually validates for us. We're missing that stage here, right?
We can do that. We actually have a
Kubeval.
Kubeval, exactly. And you can add that as a validator in the KRM function pipeline.
Exactly.
It's got some issues though, like we would have to build one that's got all those CRs, all those schemas embedded because. Right. So anyway, but no, that's a really good point.
I don't want to delve into it more, just like to remind all of us when we use the term CRD and CRs, we have to be a little bit careful because a lot of these are actually not CRs and the CRDs are actually never defined in any cluster. At least in our one.
Yeah. So I don't want to spend too much time either, but I think, John, you had a very good point, which I think we need to keep in mind, that the reality and when we will be at scale is probably a mix between things that we do in the CI/CD pipeline through KRM functions and through KPT functions on the packages, and that for our one, we are doing everything at that place. And a mix of other things that we will leave in the runtime because they just belong to runtime and it doesn't make sense to encumber the packages with them. And so keeping a tight alignment between what can be done as a controller and what is done as a KPT function to act on the packages is very important.
Yeah. Okay. Thank you. Yeah. Sorry, I didn't mean to. Everybody's hand went up. Okay. Sorry, Wim. Go ahead.
No, that's fine. Yeah. So then there is other things like garbage collection and delete. So typically it's done through the owner reference, and then the delete is typically a delete timestamp plus a finalizer, which is optional. Here we opted for, so we have similar functionality. So we have an owner reference. So if you create child resources, there will be an owner. We opted to use an annotation instead because the function SDK does not expose the owner reference. And the secondly is that we were afraid that if that would leak somehow into the workload cluster, that would be bad, right? So we opted for that annotation, and the delete is the same because also the delete timestamp is not exposed to the function SDK, so it's easier to manipulate. John.
So this is a good point. So when you say an owner reference, I'm assuming here, or maybe correct me if I'm wrong, we're talking only about things within a single package. So it's got to be because because we actually have, I was thinking about this as I was going through the package variant design proposal, and I have cases where the package variant is going to say, even beyond resources, just add some entries to a config map. And what happens when you change the package variant resource? I'm basically saying, I'm not going to track ownership of which keys I added and which I like it's, and especially when you get to, you could actually have a package variant. You could have a package variant that creates a package, and then you have a package variant that uses that as the upstream, and a package variant that uses that as the upstream. So you've got this chain, and I'm not going to try to annotate along the way every step and keep track of which package variant owns which thing. It's impossible. Like, I think we have to, because those things don't know about each other.
Yeah.
And so similarly, I think this is the right choice, and we also need to constrain it to, I only understand the things that are visible in the resource list, and that's it, right?
Correct. Yeah.
Okay, cool, thank you.
Fish, I think.
Yeah. So not having written much functions, the kept functions in Go yet. What I wanted to summarize for my understanding is that, so when whatever you did for the workshop VM, you use the functions and you wrote them in Go, right?
Yes.
Using the SDKs. But basically the problem statement that you're trying to frame is, I did that, but I saw a lot of common patterns, and I wanted to write an upper layer, which is a function runtime. Is that a true statement? I want to make sure my understanding is correct.
Yeah, that's a true statement. So it's still Go. So of course, at the moment, this function runtime is only Go. We could create it in Python and other languages as well, similar to the function SDK, but at the moment it's only Go based.
Okay.
But it's exactly as you said, it's a layer on top of what we wrote in order to make it easier or simplify these function implementations, because doing the diffing and the lifecycle management, so basically figuring out what has changed, you don't necessarily, you can do that commonly. You don't have to have the specific code. So that's
correct.
All of that handling is kind of in the function runtime. And the functions itself, they only implement the pieces that that are specific to that function.
Okay, so that means as a step one, for folks that are not very familiar with function, not having written many functions, so the functions that you still wrote in the workshop are still good examples for somebody to go and review to understand how to write these functions in Go, basically. And having an understanding of that will probably help see a pattern of what you're trying to,
See, what we could do, which this is do a follow-up on the workshop. I see. Why am I sharing this? One is I think Tal raised it. It's good that we basically discuss this across the board, right? So that's why I'm doing it, and I think it's the right thing to do.
Yeah.
And then we have to decide whether we go for whether this is the approach we go for or not, I think. But that's why I wanted to discuss this and share it, because I don't want to go all the way in. And then at the point, everybody says, okay, this is a really bad idea. You should not be doing that.
I can't say it's a bad idea because I've not written extensive functions yet, right? In the sense, it seems like that's where I see that you and John are ahead in the game, because you have written a lot of functions here, and seems like you guys have a better understanding. This is only me asking these questions to play catch up. Like, oh yeah, I can go look at those functions. So, if I look at those set of functions, I'll probably understand what you're trying to say as a pattern.
So I'll say that, yes, you can go look at those functions, but like Wim said in the very beginning of this, those were written in a hurry. Like, they don't do a lot of the stuff, right? So like, they don't track the for changes well. They don't do a bunch of the stuff that we need to do. And what Wim is proposing here is saying, gosh, we really need to, we need, because we need these to be idempotent, and we need to react to when we run essentially a reconciliation, we need to look and see, has some of my inputs changed? Do I need to re-render my outputs? There's a very common pattern here, and it's actually very similar to a reconciliation because it's idempotent like a reconciliation is. It's a very similar pattern to what we see in a controller. And so he's modeling this. I think this is great. Like, this to me makes total sense. But so yes, you can go look at those, but just keep in the back of your mind, these are those are incomplete things written in a hurry to demonstrate the happy path only.
Okay.
Tal, I think, is next.
Yeah, I'm already diving into the design a little bit, but what would stop us from having it support many KRM resources? For example, the 4 to actually accept a list. The reason I'm asking, I feel like it's a little bit limited right now because we do have, there are cases where you have multiple models that interact with each other in some way, right? So
we have that a bit, but so that's why there is a split between upstream and downstream. If you look at downstream, the way it actually, I see, and maybe that's a bit confusing, but what you see, for example, okay, so first of all, why do I have a 4? Okay, is to say that's the thing you do. That's how you have to look at the 4. It's basically that's what this function is about, right? And there is 2 types of functions, which I'll explain in the next slide, I think. One is it uses the 4 as what we call an upstream, and that 4 creates a bunch of children, right? So that's what you could say, what I call upstream. I don't know whether the name is good, but that's the name so far that is there, right? So it's basically acting upon that resource and generating children, right?
Okay.
Keeps track of that up. So for example, an example of this is interface, right? So at the package, we have 3 interfaces, okay? It will generate, so that function will generate IP allocations, will basically say, hey, I will need an NAD for it. It doesn't create the NAD. It says, I will put a condition to say I need an NAD. And there's one more thing that I forgot, but let's now assume that a new reconciliation loop comes and instead of 3 interfaces, we only have 1. And 1 changed. So what this function does is look at the difference. So it will delete the additional conditions that it was setting, right? And it will update potentially the IP allocation that has new parameters or something like that. So that's what this does. A downstream function is actually, you could almost say it's a generator, but it can, for example, take multiple own information. Let's say NF deploy, which is the last one in the list, will take all the IP allocations that were allocated, will take all the VLANs that were allocated, will take the DNN pool that was allocated, and so on and so forth. And
you're calling it upstream, downstream. I think you mean something like inputs and outputs.
Yeah. So yes, but it's also not 100%. But yeah, it's actually the upstream is kind of the one that starts it's actually the entry, if you will. That's what you call inputs, and then output is the last one. But
can we go through the list? I think Tal's jumped ahead a little bit, and I prefer, like, if we can. I think it's a valid point. Like, should that be multiple 4s? But I'm not sure. I don't know enough about what you're proposing yet to.
Yeah, so I think
I feel like we're kind of sidestep. We jumped ahead, and I'd like to, yeah.
Okay, maybe I should explain what so there is actually 2 different. So it's a single runtime, but you basically have to select: am I an upstream function or am I a downstream function? And what is the difference between an upstream? So, so in a nutshell, I think Akash summarized it in my view well. Is it does lifecycle of a child resource based upon a parent. So a parent is the 4, right? So an example of this is interface or DNN. So in the DNN, it generates a pool or it generates an IP allocation for a pool. And so what it does, it actually sees, okay, how many of the 4s do I have? It looks at the changes, whether there are additions or deletions or updates. And then it will change the life cycle of the children that are a result of that parent, right?
Okay, so it doesn't change the parent at all.
No, correct.
The parent is the input, as Tal was saying.
Yes,
but it owns child resources, and so this is the classic operate. Like, yes, it's the like controller that takes a resource as an input. It's the replica set, right? Yeah. It creates pods from a template. It creates resources from some input.
Yeah. And maybe one more thing is it's influenced by a watch, which in our case is cluster context. So in other words, because what we have to bear in mind is that these functions, they run even when it's not hydrated, when it's not yet fanned out or a variant. So cluster context, if it's not injected, they shouldn't do anything. Or if cluster context,
I would call this like a generator. To me, this is a generator, right? I generate new child resources based upon a parent resource.
okay.
I mean, I don't know. Like, we'll get to the name because you thought of downstream as generator. So maybe there's some. I
would do it the other way around, but okay.
Okay, that might be. We can debate names later. I'm just trying to build my mental model.
Yes. And also, what is important is there is two types of child resources. There is one child resource for which it has all the information, right? So in other words, for IP and VLAN, it has all the info. So it will do everything for it. So it will create or update that KRM in the package and also sets the condition for it. For a downstream child resource, for example, an example of that is an NAD, right? So an NAD is a consequence of interface, but the IP is not allocated, so it cannot generate the NAD yet, but it will set a condition. So it only acts upon conditions for it.
I guess I'll let Bala ask his question before I.
Yeah, thanks, Wim. I think this. I mean, I was obviously looked at the PR. This one part that was confusing. Thanks for explaining. So one thing I would think is probably the example that you said about the relationship between the interface, DNA, and IP pools. I think probably explaining that may be helpful for us to consume here. This particular thing, take this example, like this is let's take an example of an interface. This is what the upstream is. This is what upstream child is. This is what downstream child is. For that particular example, I think you have done some of that here, but making it explicit is, I think, is very.
No, I will do that. Yeah. So that was that will.
Thank you so much. And my very naive question is this: is there a need to distinguish upstream and downstream, or can we abstract it in a way that user could provide certain input parameters, and based on that, the runtime would decide how to handle rather than making a distinction?
Yeah, that's something we can do as well. So basically, but under the hood, what you do with them is going to be the same. So we also in the team we have had some conversation further on this, whether you could have hybrids one. Why is there a distinction between upstream and downstream? What if you have a bit of a mix? If you have a mix, our conclusion is that it's an indication that you should split your function because you are doing too much.
Okay. Can we, I still don't know what a downstream one is.
Yeah, so let's, but Vish also has his hand.
Yeah, actually.
So just before Vish, I just want to conclude, if you don't mind. So the idea is, the spirit of my question is, if the function writers can use this without worrying too much about the semantics, whether it needs to be upstream, downstream, if that semantic knowledge somehow can be incorporated, abstracted within this runtime itself, and the user would just call the methods that they deem fit, and then obviously they have to provide certain inputs, and based on that, the runtime could decide. I think a lot of this confusion could be ambiguity, I would say, could be resolved from the user's perspective. That's where I was asking the question.
I understand. Now, they will have to do some indications into the objects, most likely to do something. So they will have to do something, right? But
exactly, yes.
So it's not that nothing has to happen, but what you're saying is having the distinction is maybe a bit too black and white.
Too black and white, and it's kind of onus on the users of the function to decide and how to interpret each one of that, and then.
Okay. No, that's that's a good comment. Yeah.
Mine is related to what Bala was saying, and I was actually trying to, because I see in the kept file schema definition there is something called upstream, but I don't see what a downstream is there. So that is where I think sometimes confusion can happen too. Is
Yeah, the
downstream
word is
something?
overloaded. We
Yeah.
use that with respect to the Git repos and stuff, so it might be confusing to have those
Yeah,
words.
so I think I fully agree that the name is not ideal, and I would love to have a way better name, but yeah, so that's what we've chosen right now. We are able to change. I'm not a problem to change.
Yeah.
At all,
And in
but
this case, is the
So-
upstream
so-
that you're mentioning the same thing as the upstream that we talk about in the KPT file schema?
no.
No,
Okay.
Vish, it's no relationship there. I think.
Exactly. So
Yeah.
And so that's why I think the name is maybe confusing, but I inherited, Akash suggested it, so I took it because I rather had a name than no name, you see? So, and the ones I came up with was even worse, so.
yeah. Anyway, that's the point I was trying to make, because sometimes these terminologies or the semantics we use can be.
Yeah, for sure. And I think this is one of the things. So, but let me first explain what the downstream is, right? Maybe, because that will help. A downstream, at the end of the day, is also acting upon a for, but there is the difference between an upstream and a downstream is the upstream has a specific input and it acts upon it, right? The downstream is dependent on potentially other inputs before it can determine whether it's ready to execute. So to give an example of that is take NED or take NF deploy. In NED, for example, let's say the IP is allocated, but the VLAN is not allocated, and I need to generate. So it will. So there is a readiness associated with the owners before the for can be acted upon. You see.
So would the for, well, see, maybe I'm using the terminology differently.
Yeah. And so
I might, let me ask.
Yeah.
If it, say, take the NAD, which has required inputs, sorry, I'm gonna sneeze. Would it, I guess, the function that creates an NAD would own the NAD.
Okay, and that's maybe I need to change the terminology. So, but I use it the thing of a controller. That's why I said it acts upon the for, but it actually generates the NAD. Yeah. So and
right. So the for that it's acting on would be that list of things that are inputs.
Yeah, and that maybe
then
also and maybe also addresses.
NAD.
Yeah, Tal's comment is that in this case we should reverse own and for. But typically the reason I did not do it is that maybe I should explain you. So here is an example.
This is helpful. Okay.
So this is a diagram that actually details how this will act or how they operate for release 1. Okay.
But what's so the own and the for and all of that, it's the function that owns it. The function's for something and owns something, and
yeah. So the way the terminology is the following, and I will make this. This is a downstream child, right? So I did not. So okay, how to read this? Sorry, I'm editing it. Is it big enough or?
yeah, it's big enough.
Yeah. So how this works is okay, or how it's modeled right now is a for. So this function acts upon the for, and it is dependent on the watch. So if there is no cluster context, it will not do anything. Okay. If there is cluster context, so that's what the watch is. So it depends. So there is something that it needs in order to figure out whether it will influence the behavior of the function, right?
So the interface function, the interface already exists in the
package.
In the package, right? Yes. So the input to this function is basically the interface, and that's sort of the primary controlling input.
Yeah.
And ancillarily, it needs cluster context. So we say watch on that,
Yes.
and then it owns VLAN IPs, and it owns it. See, it actually creates NADs, or they're separate.
And that's what the difference is between a downstream child and an upstream child. And again, maybe the name is not good, But an upstream child, it has all the information to generate. So in this case, it generates the resource plus the condition. Here, it only generates the condition and not the KRM.
Why would it need to know anything about nats? If it's not creating them, I would prefer it doesn't even know that they're a thing.
Yeah, so then NAD will never know. So then NAD function will have to look at interface before it can do something. So the way. So in other words, now we create interdependency. So the interface is kind of the thing that says, hey, I will need an NAD, I need a VLAN and an IP based on the content of the interface, right? But it doesn't know how to generate the NAD. And then the NAD, so it will set a condition to say, I need an NAD. And then the NAD will act upon that. So NAD is a downstream, will act upon.
You're saying that. Yeah, it's about where we build in the knowledge.
Yeah.
And since we don't want the user to have to put an NAD resource, we want somebody needs to create. Well, we have the NAD function.
Yeah, the NAD does it, and so the way the design is, it uses the condition because that's its trigger to act upon, right? And then it sees it needs it will have the interface to basically get the CNI type. It will have the VLAN the VLAN allocation and the IP allocation. So these are the input that he has, and it will check whether they are ready to be consumed in the readiness gate. So if you look to the runtime, what it does, it says, so you define these are own objects at the moment, right?
Right.
And maybe the name is confusing, so maybe we could also give another naming, or depends upon. So yeah.
No. It's yeah. I see what you're doing, and I'm just not sure. I'll let you finish talking.
Yeah. Yeah. So the idea. Yeah.
So at the same time, since we talked about VLAN and NAD with respect to interface, I would like to understand NF deploy, right? You put own. So does it generate in which fashion the interface upstream?
No, so when the difference, so that's the clarification between an upstream child resource and a downstream child resource, right? That's why I'm adding it here into the text. I did not do that properly. I actually did it, but it was not explicit with the name, right? So here, so the difference is, so this is an upstream child. What is the difference between an upstream child and a downstream child? We can go to this text. Is an upstream child, all the information is available. So it generates the full KRM as well as the condition.
Okay.
Downstream child, it doesn't have all the information. So it actually only generates a condition.
Right. So you're saying.
So my question is, if you go back to the table, sorry, Jack, just a second. So basically, in this particular case, I'm looking at the very first row, interface. So when it says downstream child for the NF deploy, basically it is going to generate a condition for NF deploy.
Correct. So this is only a condition, yeah. And so you see that there is duplication, but he will say, okay, the condition is already there, so that's fine, right? So it will not influence these things. It will just, if the condition is already there with our libraries, they take care about that.
Okay, thank you. Yeah, go ahead, John, please.
Yeah, so I was just going to try and talk it through and see if I can understand. So this comes down to, like, there's two approaches I can imagine here, right? One is the interface knows, hey, I'm going to result eventually in an NAD. And in order to get to that, I need to generate a VLAN and IP allocation. And I've got all the information I need to do that. So I'll do that. But I do know that I'm going to get to an NAD. I'm aware of NADs, that they're a thing.
And it has the information to know, because there is interfaces that don't need NADs and there is interfaces that needs NADs, okay?
Okay. So then the other option is to...
And it's also for VLANs and IP. Typically, an interface will always need an IP, but a VLAN is not always needed for IP. If you have a loopback interface of a CR, of an NF, you don't need to have a VLAN. and you
Right.
don't need an NAD. So,
Okay.
so it also knows the context when to, so that's not clear in this table, of course, but because it's too much, but it's not for every interface. I always need these 3 objects. It's depending on the content of the interface CR, it will either need some of these.
Okay, so that's building the knowledge of NADs into interfaces. The other option is to have the NAD function look through the resource list for interfaces and determine whether any of them warrant it creating an NAD.
Yes.
Or not. And you're doing that, but you're doing it via condition, which limits the knowledge, the logic, I'm assuming, puts the logic, you use the condition to move the logic from the NAD function to the interface function.
Yeah.
And so basically what you're saying is I can do it either way. The question would be, if these things are so intricately tied together, would you use the NAD function ever without the interface function? And if not,
so, yeah, at the moment not. At the moment not. But what I can imagine is that later on there is another object that needs NAD, which are not interface related, and then it would work the same way. Yeah.
But then NAD would have to know how to interpret that
other object and yeah, that other object again.
Okay. Yeah, it's an interesting problem. I'm not sure what the right answer is. You could almost just roll the NAD functionality into the interface one because it's basically then becomes all.
No, you cannot because there is a dependency on another resource like IP VLAN needs to act before they can go here, and interface needs to say I need an IP, and so there is. So what needs to happen if you look to the sequence, because is that interface should run at some point. He will say I need an NAD, then VLAN IP allocation will have to run or have to have the proper.
Right, but interface will get executed again after that happens.
Yeah, it could. This interface could execute again, even if the VLAN and IP are not allocated. If there is no change, it will not do anything. It will not change anything. So that's what the lifecycle does. And then at some point, everything is fine. And then NAD executes. It sees that all the conditions based on the owner, so it knows what it's dependent upon, and it will then act on that. So it's split. So that's what the difference between upstream and downstream a little bit.
Yeah.
Is that you see that there is a dependency.
Yeah, like I think that, yeah, this works. And if we had another potential input for NAD that would then it would be very clear. I think that right now it's probably you could embed it in the interface function and just like now when you're setting the condition to true, instead of that logic, you'd have generate the actual NAD. But if that's the only input, if there's multiple inputs, then I guess there are multiple inputs. There's the interface function is aware of all the inputs. And so it could generate the NADs too, but I think it's fine to split it out. And eventually,
the architecture right now, what we said is if you don't have all the interface, all the information, you don't act upon it. And so you don't create or update it because it's the guy underneath that actually will do it. And you also never delete in an upstream. So you give an indication you should delete, but you should not act it upon. And the reason we did that is mainly at the moment for the IP allocations, because otherwise, if you just delete the IP allocation and the controller doesn't act or doesn't know about it, okay, we have a refresh timer in the IP allocator that will time out, but it's typically long, right? So this will give us an explicit way to delete the IP allocation as also clean up the backend.
Okay, so we are at time. I can keep going, I think. Check my calendar.
Yeah, same here. Interesting discussion. Let's finish it.
Yeah, I would prefer to finish it now, but so I guess we'll record it and maybe we just keep going and hopefully anybody who's interested can stay. If you can win.
Yeah, no, I can. Yeah, not a problem.
So how much do you have left, Wim? You think that you want to
Oh,
go?
I mean, I can, yeah, so I think that's the slide. I have an example on how we apply it. So that's the other thing that I have an example of an interface and I have an example of an NAD.
Yeah, if we can take like, so conceptually, I like all of this. I probably find the names a little confusing too.
Yeah, I agree with you. So another option or is exit and entry and exit, but that's also a little bit, yeah. Any suggestion, please welcome. Input and output. Yeah.
So other thing is what I requested, Wim, is keep keep all these things as your internals, right? And write one abstraction interface and provide that to the function writers where they hide, where they can mention whether it's I don't know, again, it's a challenge for us to provide that abstract interface on top of this, the libraries that you've written. Just one simple interface where the user could say, this is my function, this is the operations I want to make. And somehow they need to indicate whether, instead of calling it upstream, downstream, they need to indicate whether it is the original function or it's a generated function.
What about?
We'll talk a bit of that, but you see, actually, the guys are implementing at the moment as we speak. So, and maybe it's best to go through some code. I think it's good to see some code.
Because
Yeah, we can do that. I think I wanted to just say, primary. We can debate late names later, like I said, but on the issue. But primary and secondary might be a little, to me, a little more clear. Like I'm the primary owner of this thing. I'm the owner of this thing. It's a primary resource for me, or I'm sort of the requester. Or that's another one. Like so we can debate names, but John Marie has a hand up.
Yeah, I was going to say the same thing. It looks to me that the difference between what you call upstream and downstream is that in terms of upstream, you know everything about the resource and you are the sole owner of the resource, while in the downstream, it's an incomplete. So that would be more something like complete, incomplete, or this kind of concept rather than upstream, downstream.
Yeah, we have to think. If I would really help, I like people to come up with names. But so you see at the moment, when you call the runtime, I call a new upstream. So that's how it's, and that's where Bala's comment is. Maybe we should try to hide that and have some parameters here that would help. So I'll take a look at it, but this is how it looks right now, right? So what you do, you have a for, and this is basically a KRM resource. So this API version kind, right? And you have a populate function. So this is the function that actually is going to do the work to where all the magic happen. I'll show that in a bit. Then you say, here are my owns, right? So this is again the GVK, so the API version kind thing. And here you indicate, and okay, I will call this upstream and downstream. At the moment, it's different, right? So, but I will call this an upstream child, or maybe, yeah, again, depending on the naming that we come up. But what this indicates is actually the difference between an upstream child and a downstream child, actually. Okay. I did not update the code yet. And then here you say, I have a watch. I'm depending on this resource. That could be multiple. So it's not a single. So that could be more than one. But in this example, it's only cluster context. Okay.
So when I think of owns, I think of owns meaning I'm responsible for its life cycle.
Mm-hmm.
I have to delete it when it's time to delete. I have to request its delete. I mean, the actuation of the delete might happen by a different control.
So in this case, own does that. So it either creates the resource in case it has all the information, right?
Okay.
Will put a delete annotation on it if it has to be deleted, and then it's the downstream at the moment that acts upon the delete. So it's like a finalizer operation. And then for the so the difference, if the own, so you actually either generate a full KRM if you have the data, and then you set a condition. So our thing is always a condition is kind of a bit of a, I call it a work, saying that there is work to be done. It's an indication to signal to the secondary, if you call it, or the downstream to say, I have work for you. You need to act.
Yeah, I think what might be happening is we're shortcutting. I'm just trying to go back to the controller analogy. And in the controller analogy, we have a spec and a status. And when we are what you're calling your upstream child, we are actuating we're actuating the spec, and then in the downstream child we're not. We're like, I feel like we're missing a resource like in between. Yeah. It's that, or we're missing a. We're almost like we're using a condition to say, look at me and generate something from me to a separate function, as opposed to using an intermediate resource to tell that function what to do. That's my suspicion and why it's a little confusing. I don't know that that's necessarily a bad thing, because these aren't controllers, they're functions, and it's a function pipeline. It's not a full bore API server, but that's kind of where my mental
Yeah, that's why I call it, John, the conditional dance or the conditional choreography, because it's the that are the signal between these functions that tell that, and this condition, actually, that's not what you have in the controller. That's also in my slide why I say, if you look into the slide that I put here in the comparison, it actually works. Signaling works. So this is actually that's the piece that we are discussing right now. It's the conditions are not just status, but they are actually, they're doing two things.
Well, that's true in the controllers too, right? Like it signals the service controller to add pods to an endpoint, the endpoints controller to add pods to an endpoint slice when it sees the readiness state. So it is the same thing. I think there is something more it's doing in the, anyway, like there's something there. I don't know if it's meaningful, but let's keep going. I don't want to derail things.
So, okay, so where was it? Yeah, so this is the own. So here you basically say these are the resource, and I need to change this to indicate the difference between the two, but that's what they are planning to do here. Then for the watch, you basically say, I'm depending on the cluster context in this case, and you get a callback function to actually get information on it. And then you have a condition which is acting upon the watch. So that's kind of what you have. And then you do the run. And then you have to implement these callbacks. So you implement the cluster context callback. So you get, actually this check is not needed because it will be that one. But what I'm doing right now is I'm checking whether the side code is there, right? If that is available, because then I know where we need that to know where this gets scheduled, right? For the IP allocations and the VLAN. I have so this is the condition. And so if side code is not available, I will not do anything. And so that has the influence. And then this is just a populate function. So it basically looks at, I have the interface. It tries to understand the details. If the CNI type is not present, right? So that's when I only generate an IP allocation. If there is, the CNI type is present, I'm going to generate an IP because I have all the resources. And I will allocate the NID. It's actually it's setting the condition, basically, because it's a downstream acted upon thing. Yeah, so this has to change a little bit still, because we were generating the NID, but we removed that. So this has to change. So that's basically what you have to write.
Okay.
Yeah, that makes life easier.
Yeah. This is totally tangential, but like probably we want to make it configurable, whether it's what the site code versus, right now we pull site code from there, but like in a map it to a label or something like.
Yeah, correct. Yes, so but that's semantics of CRs, how we modeled our CRDs, right? But so,
Yeah.
so, but you see, that's the code you have to write, basically. I have also an example of a downstream,
You know, like,
right?
I don't want to do, like I said, it's a tangent.
But you see, I think what I like is you just, the only thing you have is you say own for and watch, right? And then you just have to add some functions here.
So it manages all those annotations and it manages
all of that is
life cycle, when it should be deleted, and
all of that is handled by you. I actually can show it even.
Yeah, I'd love to see that. Yeah.
So here, for example, I generated it. So this is a package, right? That's the package that is in our example package. I changed all the conditions here, right? I just remove it. So here is I was putting the context. So here, yeah, so I evaluate this package and I run. So this is, what am I running? You see here, I generate the IP allocations, right? And I set all the conditions. So that's basically what will happen. So it's rather simple.
Awesome. Okay.
If I change some of these things, so let's say I delete it, right? And then I run it again. I think, but yeah, I have to refresh it, I think, or there's a bug. I think it recreates all the conditions as well normally, I think, or maybe.
Should, right. Yeah.
Yeah. So it's doing all that stuff. So if you change something, let's say I delete an interface, or let's say I don't know whether everything, we haven't fully battle tested it.
Sure.
And I can change, for example, yeah, okay, I know, yeah. So you see, yeah, there is still some bugs left and right, but the whole idea is that this should all be handled in the background for you.
So this does not require any pipelines in the KEP file. I was just,
Yeah. So okay. So at the moment, so this is
He's running it manually.
Yeah, I'm doing it manually. So basically, I say run. So this, if you would put this function in the pipeline, it would execute as part of the pipeline. At the moment, I'm doing it manually. So
okay, but the expectation is that people will be using the pipeline, right?
In reality, this is just for debugging, right? So for testing.
So now what you bring up, Bish, is an interesting point. Something we've talked about in the KEP world is like, we actually should be able to inspect your resources and determine functions to run based upon what's in your package. So you don't have to put it in the pipeline.
Yeah.
But that's fraught with complexity. So we've never gone there. And, but maybe over the next few months, we'll figure out some thoughts around that.
Okay. Again, like I said, this is my limited understanding. What I know is somebody could go look at the KEP file and the KRM resources out there. And pipeline is where you actually apply your validation on your mutation, is the way I look at it. That seems to help somebody follow the flow, right? It's more.
Normally you'd put that in, like when these packages become final, that'll be there in the pipeline. But for development purposes, it's easier to just run it manually.
Okay.
Yeah, so here, this is a previous example. So we did some prototypes. So the reason why we came to this conclusion is because we were implementing. So this is already having libraries, but here you actually have to then keep track of them and stuff like that. So here, this code would be you basically duplicate this code every time you have it. So that's all gone. So you see here, here you have to deal with all the updates and stuff like that. So we put that all back in.
That's
awesome. So yeah, this is 300 lines and this is 100, I think. There's more.
Well, it's not only the number of lines, but it's that it's bugs are in one place that you can fix them once.
Yeah, also, yeah, correct. Yeah.
Okay, so it's super helpful now. I can go review it more easily and understand what the heck's going on. I think we can debate names over the issue, but the general direction seems really good. I have some questions, like I said, about like whether there's slightly different ways to do it or where we're building in the knowledge between resources, like this resource knows about these resources versus, you know, whether that can be isolated or not. But none of those are all refinements, I think, that would be made over time.
Yeah, we can. I see that the problem. The challenge we have is the following. Okay, we have very little time.
Exactly.
So I don't believe that this is final either, right? So as you said, this needs way more thought. I would love to have people. I have a number of people review it. But yeah, let's first do Tal. Yeah, Tal, you have your hands.
Yeah, I just want to point out too, this is in many ways great. You know, it is like a comprehensive way to write functions. I think if the design is solid, there's nothing Nefio specific about this, right? The library itself. I think this is something that could be contributed to Kept.
Yeah,
it could be, or yeah, absolutely at some point. I think yeah.
Agree. This is not Nefio specific. I fully agree.
It could go to the kept function SDK, right? Like it's a way to, yeah, eventually.
I agree.
Bala?
Yeah. I think this is a step in a great direction. I think like we all discussed, we all agreed. I mean, we can always iterate going forward, right? So, but this is in the right direction, and this is gonna make our life easier for the R1 and beyond. And obviously, if we had to refactor, add new things, we could do that. The only two things is obviously one is my wish list here. Like if you can write one abstraction on top of it where the user don't have to, the onus is not on the callers to decide. Maybe they have to provide some inputs, but not exactly the internal semantics of upstream, downstream, upstream child, downstream child. Those things could be determined internally. That's one thing. Obviously, the other thing is that we discussed about is the naming. If you could,
naming is important, I think. Yeah, the sooner we have a conclusion on that, yeah, and it's yeah.
So other than that, I think it's a great first step. Actually, this will make a lot of our life easier. Thank you so much, Wim, for doing this.
Yeah, it's awesome. Solves a bunch of those problems we ignored in the workshop.
Yeah, I mean, we had no time.
I'd like to add one more point, and this is definitely looking ahead. But you know, if this becomes solid, something that I'd really like to see is Python implementations. I think Kept especially lends itself, you know, because it's manipulating data. Python is such an easier language to do these things than Go, with the pros and cons. So I can definitely see, you know, Python version of this SDK as well.
There's a Starlark SDK, I think, Tal, so we could build also a Starlark version of it.
Yeah, so the Starlark thing, what it does is it allows you to embed in your function config an actual bit of Starlark. So you actually can write functions, but Starlark is not Python. It's a subset of Python. And in particular, I believe regexes don't exist. So basically it's trash, in my opinion. Like it's not that very useful. I mean, you know, I sometimes am hyperbolic in my language, but it's not what I would prefer to use. But I agree, a Python SDK even would be nice. But what the problem with function like this is really good because it's for building functions that are reusable. Similarly, if we built a Python version of this runtime so people could write reusable Python functions, that would be really good. What I don't like about the Starlark, like the put your code in a function config, is that it begs creation of package specific functions as opposed to reusable functions, which you need, right? So you sometimes need those, and it's fine, but it's like, it's not our, like, we want to build something that understands this resource and we can use in any package, not that we have to carry the code with it. But both are needed. So, and that's a secondary, that's a different point than you're making, Tal, that being able to build a Python function and compile it as a container image and consume it as, whether it's written in Python or Go or whatever, you don't care, I think would be great. Yeah.
Right. The point is, at the end of the day, we want to make it very easy to onboard solutions, vendor solutions into Nefio. And look, honestly, our mechanism is very complex. It takes a lot of time to grok. But at the end of the day, it's rather simple. The idea that you mutate deployment packages. So if a network function vendor basically needs to supply a Kubernetes operator or possibly a Helm chart to actually handle the workloads, but then the shift left customization stuff could be, you know, a rather simple Python script that uses the SDK. So that's the other part of the onboarding that needs to be done, right? So because they would have maybe their own, you know, you know, what they're watching could be their own special KRM types that involve. You know, that's part of our discussions about the meta models, right? To allow things to be extended in a certain way. And that's kind of what I tried to show with Kplug, right? That you can take those extensions and basically delegate them to some sort of script that does it. So, right. Eventually, we want this to be very easy. So that's why I'm thinking Python could be a very friendly way. But I know I'm definitely skipping ahead. Yeah. It's not a theme for R1. But I think a theme for future releases of Kubernetes of Nefio, future releases of Nefio might have different themes, and one theme could be onboarding, like improving the onboarding experience, right? So this is a step in that direction for sure.
Mm-hmm. Yeah, Liam.
Yeah, just one point maybe on that. I suppose the only thing that I'd be reluctant to go away from Go would be that, you know, sometimes you start, you know, I've seen it in other systems where if you go away from sort of the language of the system, you know, it might make things easier in the beginning, but then when you want, maybe, you know, your first or second iteration of your function might be, you know, simple, but then suddenly you decide then that you've got to do something that's a little bit more complex, and you can't get into the APIs, and you don't have the support of the modules that's there already. So that's just kind of a caveat on that, you know.
Right.
Yeah, that's a good caveat, and I think that's an important point, for example, working with Kubernetes controllers. But we're in a very different domain. This is all about data manipulation. That's it, right? So, or potentially you might have you know, customization code that calls other systems. But the point is that a lot of times those other systems are not written in Go. They might be written in Java. You know, so whatever it is you're doing, you do need that kind of flexibility. But anyway, we're definitely jumping ahead here.
Yeah, we're digressing, but yeah, that's I've also thought about actually I lost my thought. Anyway, I think so what do you folks think? I think we're at a point now, I feel like I've got a good enough understanding. I can go review the code. I feel like it's even as is, other than the naming and the points Bala mentioned, like probably basically a great initial cut, and we'll iterate. Like, so any other big questions before or shall we wrap up for today, since we're half an hour over?
Yeah, I'm wondering whether we should discuss it. Should we, or are you going to discuss it with the CAP team, John?
I could. I think it's going to require them getting up to speed on some of this stuff. So I would rather we iterate and prove it out. And like, they understand what we're doing in Nefio and like package variant and stuff, but like now we're talking about, and obviously the conditions piece that Morten implemented in order to support all of this stuff. But I think we're a step ahead of where probably most of those folks are thinking. And so I don't think we need their input, if that's what you're asking for.
Also, I think the point that you raised, I don't know, maybe it's not the CAP team, but someone else is like, the point that you raised is, are we doing it in the right place? And is this here? And is this, yeah. But okay, okay.
We'll learn that. Like, that's an iteration thing, I think.
Okay.
Oh, I remember what I was gonna say is, you know, we talk about data manipulation. We actually could build a SQL interpreter. I love SQL. And actually write functions in SQL.
Access to.
So anyway, all right.
Okay,
thank you, everybody.
Yeah, thanks.
And we'll anybody who's joining the UI meeting tomorrow, I'll see you tomorrow. Otherwise, we'll see you next week.
All right.
Thanks
all.
Thanks a lot, Ben. Really appreciate it.
Thanks all for the feedback, by the way. Yeah, great.
Bye.